Okay, so this lesson talks about permutations and factorials. So a permutation in math is a way of arranging objects. Okay, so let's put these markers, pens in an order. So would you agree I could go yellow, pink, and then green if they were to line up? That's one, right? I could also do this. I could go yellow, green, pink. Okay? Lauren, you're counting. How many are we at? 2. I could go green, yellow, pink. Yell it out. 3. I could go green, pink, yellow. I could line them up with pink and then green and yellow. And then I could go pink, yellow, green. 6. That's it, right? Anybody see any other ones? Okay, so that's me lining up objects. So that's what a permutation is, arranging objects in an order. Okay, so how many arrangements can you do if you have 6 children and they're lining up at the water fountain? Okay, so here's what I'm going to do. 1, 2, 3, 4, 5, 6. 6 positions that they could line up in. So how many options do I have for the first position at the water fountain? How many kids could I put there? I have 6 choices of options, right? Then somebody's standing there. How many kids could potentially go into the next spot in line? 5 kids. Then how many kids could I put into the next? 4, 3, 2, and 1. Okay, and then the math operation would be multiplying. Okay, that's the same thing I did with the markers. Okay, when we did this thing, there was 3 pens I could have started with, then 2, and then 1. So 3 times 2 times 1 is 6. Okay, so this is a factorial, and this is how it would be written. 6 factorial. Okay, so a factorial means I'm multiplying in a sequence, starting at a number all the way down to 1. Okay, so this is my regular calculator. I can do it quickly. I just go 6, second shift, the exclamation. This calculator, here's where your buttons are. You have to push 6. Then you have to push the math button. Then you have to go to the probability. So math button, probability, exclamation.
Yeah. She's in the wrong one. Yeah. It's on. If you need it, you can get it from that. What is that? Oh, I got so scared. Okay, we do.
Okay, push 6. Okay, everybody's good there? 6. And then the button right here, that's called math. And then at the top, this says probability. And then you can see number 4. 720 ways you can arrange those kids. Anybody not find that button yet? Math, probability. Okay, so factorial notation is always written in a descending order. So if I do n, then my factorial would go like this. N minus 1, n minus 2, n minus 3, n minus 4, and I would keep going down like that. Okay, so evaluate. So give me a 10 factorial. Practice your typing that. 10 factorial. Can you find the buttons and push it just to make sure we know where the buttons are? So what kinds of things would I use this for? If I told you that I wanted to make a batting lineup for a softball team and I did 9 factorial, that means that's how many ways I could put those people in a batting lineup, which would be a lot of different ways I could make batting lineups. Okay, well this is a 10 factorial. Okay, next. I'm not going to do this in my calculator. Here's what we're going to do. I'm going to start expanding 12 factorial. Okay, so 12 factorial would be like this. 12 times, what's the next? 11, 10, 9, dun, 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 and beyond. Why did I stop there? Because there's a 9 factorial on the bottom. So 9, 8, 7, 6, 5, 4, 3, 2, 1 on the top with that would cancel with the 9, 8, 7, 6, 5, 4, 3, 2, 1 there. But now there's a 3 factorial. So 3 times 2 times 1. Okay, so you could have done that one on your calculator, but what if I give you one that you can't do in your calculator? So for instance, 100 factorial you can't do in your calculator. Why do you think that is? It's just too big. Think about that number, 100 times 99 times 98 times 97, right? That's huge, and your calculator can't handle that. Okay, so that's where you would kind of apply that. Simplify. So this one is n plus 3, n plus 2, and then and beyond, and beyond, and beyond. So really, why didn't I just start at the n plus 3 and go down? Okay, next one. Which one of these is bigger? The top part or the bottom part? Top. That's a bigger number on top. N plus 1 is a larger number than an n minus 1, right? So n plus 1, what's the next descending of that? Just an n. And then I'm going to go one lower from that. N minus 1. And beyond and beyond and beyond, right? I stopped there specifically because it matches the bottom. So all that and beyond will cancel all that and beyond. And this is what I'm left with. But it says to simplify. What does the word simplify mean? Multiply it out. Okay? So this is some of these parts in this unit get a little pre-calcy. Okay, so this one, which one of these is a larger number, n or n minus 2? N is bigger than n subtract 2. Okay, so n, go down. And minus 1 is down from that. And minus 2 and beyond. Okay, so now applied brains. I'm going to show you one way. Pre-calcy brains, I'm going to show you the other way. Okay, applied brains, this number and this number are back to back in order in math. Just think about two numbers beside each other that multiply to 90. Can you do that in your head? Two numbers beside each other that multiply to 90. This would have to be a 10 and this would have to be a 9, right? So n would equal 10. Right? If this was 10 and this was lower, 9, that would be 90. Okay, pre-calcy brains. So if you're not even want to look at this, that's fine. You don't have to look at it. Pre-calcy brains, you would have multiplied this out, n squared minus n. You would have made it into a trinomial. And you would have factored it. 10 times 9. Okay. But n is not allowed to be a negative number because you can't do negatives in factorials, because the lowest factorial you can never get down to, you have to always stop at 1, right? Right? So when you're lining up factorials, can't go past a 1. Okay, next page. Matt downloaded 10 songs. He wants to create a playlist using 6 of them in any order. How many different 6-song playlists can he make? Okay, so how many songs can I put as my first song? How many options do I have? 10. Then the next song on my playlist, how many options would I put there? 9, then 8, 7, 6, and 5. Okay. You can type that into your calculator, but this is what that is. You had 10 options and you're arranging with 6. Okay, so this is, for me, easier to type in my normal calculator because I just go 10 and then there's this button right here, second shift 6, like that. Okay. On your big calculator, if you're using it, I need you to type 10 on your screen. Then you hit math. Then you hit probability. And then you do the P, number 2. And then you hit 6 after that. Okay, so you have to push 10 before you go into that menu and get that. Okay, so that's how many different arrangements you can do. Okay, Tanya needs to create a password so she can use any digit and or letter of the alphabet. The password is case sensitive, so lowers and uppers are different. It has to be at least 5 characters long or up to 7. Each character can be used only once in the password. How many different passwords are possible? Okay, so let's talk about the different scenarios. we can make a password that's 5 characters long, 6, or 7. Okay, so here's what's happening. How many options do I have available in my password? I'm allowed to use any of these digits, so how many options is that? 10. I'm allowed to use any lowercase letter. How many letters are in the alphabet? 26. Plus, I'm allowed to use any uppercase letter. So I have 62 options of things to put onto my password. So on a 5 code password, I could do 62, 61. Does that make sense? Because I'm only allowed to use a character once. And then once I do that, I can't repeat it. Okay, what's another way for me to type that into my calculator? How many options are there? 62. And I'm arranging with 5 of them. Okay, then what do you do if you had a 6-character password? It would be 62 options, 61, right? So in other words, this would be written like that. Okay, what am I going to do with these different scenarios there that I could have had either this password or this one or this one? So what do you think I'm going to do? I'm going to add those 3 values together. Because this password or this password, I'm not picking them at the same time. I could do this or that. So in math, you would add those scenarios together. So I need those 3 numbers added together. It might be really big. You guys know what scientific notation means? Like that? Pretend this decimal is 12 places over, right? Like that's a huge number. Is that what you're getting though? What would I have done differently on this question if this wasn't on this? Each character can be only used once. What if I didn't have that sentence and I could use repeated characters?
All of them would just be 62.
This would just be 62, 62, 62, 62, 62. Right? Does that make sense? Okay, so now the next one, you're doing the same, except for you just have one option. You have to have 8 characters. So which one of them would be more secure? This option or this option? So this option says there's just for sure 8 characters. So 62P8. Is that number going to be bigger or smaller than that option? So which option is more secure is what I'm asking. What's better when you have passwords? The more options, then the more secure it is, the harder it is to guess, right? Okay, more options means harder to guess equals more secure. Okay, a used car lot. 7 different car models are parked on the street for viewing. Okay, there's my 7 cars. Okay, question A. There's 3 red cars. They need to be parked at the ends and in the middle. I have to put red cars on the ends and in the middle. Okay, so here I go. I'm going to put a car right here. How many options do I have? 3. I have 3 red cars to pick from. Then I'm going to put a car in the middle. So now I have 2 red cars to pick from. And then I'm going to put a red car on the end, and I only have 1 option left. Now I need to put a car here. How many cars do I have left? Should be 4 cars left, right? Because there's 7 cars, so I already put 3 reds on there, so now I have 4 cars left. Now I have 3 cars left, 2 cars, 1 car. Okay, this is not a formula one. You literally just have to go in and type 3 times, 4 times, as you see. I guess if you really wanted a formula, it would have been the 3 red cars, the 3, 2, 1 for the red cars, and the 4, 3, 2, 1, but okay, question B. The 3 red cars now want to be grouped together. So the 3 red cars have to be placed all beside each other. So I'm gonna circle like that to say those 3 cars are sticking together. Okay, can you visualize this? You could put them all here, you could move them into the middle, you could move them to the end, you could put them second, right? Do you see what I mean? You could go like this. Okay, you could go like this, right? You could move them around like that. You visualize what's going on? Okay, so here's the deal. When I move them around, it's kind of like treating them like one unit. So I could move this. So 1, 2, 3, 4, 5. They're treated like one car kind of. When they move, they are treated like one car. So I could really arrange with 5 items. But what could I do inside the grouping? I could move the red Mustang beside the red Cavalier or whatever, right? So then I could move the red cars around within its own glued together section. Okay, one more page I think I have to do. Okay, moving around stuff when you have identical objects. Okay, so the word dad, let's pretend I moved these D's around. Okay, I moved the D's around and then it made a different arrangement. But does this arrangement look any different than that arrangement? No. So in math, when we have something that ends up being the same, we would just cancel it. Does that make sense? What math operation makes you cancel something? Add, subtract, multiply, or divide would be a cancellation. Divide. Okay, so here's what we're going to do. How many letters do you have to move around altogether? 3 letters can move around. But how many letters are repeated? So then that only ends up being 3. So that's the format. All divide by repeats. Okay. So, here we go. Tom stacks 7 dinner plates. He has 3 white, 1 red, 1 yellow, 1 blue. Okay, so how many ways can he stack them in the cupboard? So what is the all? How many plates can you move around all together? 7. And there was 3 whites. So in my cupboard, if I put this white on top of that white, or vice versa, I can't tell, right? Because they're the same plate. So then that would be, and then you'd have to calculate it. Okay, so on your test, what would you be looking for on that question? Letters in words moving around. You would look for plates. You know what other one would be? Money. If I move around quarters, dimes, like that, okay, you can divide by the repeated because I can't tell if this quarter, that quarter on top of each other move around. How many ways can the letters in Canada be arranged if the first letter must be an N and the last letter must be a C? Okay, so I'd have one option to put an N. I'm going to cross it off. I would have one option for putting a C. Then in this section, I'm going to put any of the other letters. So what am I left with? I have 1, 2, 3, 4 letters to put anywhere. But 3 of those letters are A's. Right? Because I could go A, D, A, D, A. Do you see all my 4 options? That's only options, right? Okay? Because it doesn't matter to your brain if I move those A's around. Okay, so the last type of question, there's 2 of them, but it's the same type. How many of the ways can we go from home to school and we can only go east and south? So right and down. You can't move left or you can't go back up. Okay, so if we start here, there'd be one way for me to move there. There'd be, if I start at the star, there'd be one way to move down, which means there would be two ways to get to that intersection. Does that make sense? Because how could I get to this intersection? I could go over down, or I could have gone down over to get there. Okay? Ones are always on the sides because there's only one way to move across, 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 across. To get to this intersection, there would be three ways. I could move over, over, down. I could move over, down, over, down, over, over. 4, 5, 6. This would be a 3, and this would be a 4. This would be a 6. What am I doing? Adding. This would be a 10, 15, 21. Keep adding. Okay, so how does this relate? Okay, so there was 5 ways to do that, and 3 going down. So here's where this number came from. So 5 and 3, there was 8 directions altogether. 5 repeated in that direction and 3 repeated in that direction. So if you type that in, it'll make 56. Okay, but most people just prefer the method on the chart. Okay, FYI, that would need to be in brackets if you're typing that in, right? So that would be another kind of thing to watch out for. Okay, so last one. Okay, so 1, 1, 1, 1, 2, 3, 3, 6. Okay, so now that you're done one block, you can either reset or carry forward. So if you carried forward, it'd be a 6 and a 6, which would make 12. Then you would carry the 12 forward. Okay, so keep adding. Keep going. I'm going to do it the other way. Okay, so I did it in 2 different ways. So the first way was that I carried the 6 forward, and then the second way I just reset to 1s again. Okay, you can do it either or, but on the method 2, when I reset, these were all the 3 numbers I got on the corners, and I multiplied them. Okay, and obviously on the method that you carried it forward, just whatever you get at the end. Okay, but mine matched.